In this video, I'll do exercise number 424, which I believe is in intermediate class. I believe this is class number 3 assignment. I'm going to draw this entire view in 2D, especially the right side, because I can mirror a lot of the right side across the center line to form the left side. Again, I'm going to do it in 2D and then extrude the 3 areas. The center should be the thinnest. The flange, I guess you'd call this, would be the next thickest, and the bearings, if you will, would be the thickest. The dimensions for those thicknesses are over here to the right, 1/4 inch, 0.5 and 0.7. By centered, I mean slicing this straight down the in half. Each side should be identical. The 1/4 inch should be centered in the middle of the flange, in the middle of the bearings. I'll start with drawing the top 2 circles. All 3 of these bearings, I call them, are the same diameter. So I'll start with a 1 inch diameter big circle, and the smaller circle is 5/8. All 3x means all 3 are identical. I'll start with circle center diameter, pick a point, starting with a brand new drawing. Diameter of 1, zoom in a bit, click circle diameter again, hover, O snap, and the center section should be 5/8, or type the decimal. By the way, I got dynamic input on, polar tracking set at 90 with no additional angles, O snap tracking on, and the usual 5 O snaps, end, mid, center, quadrant, and intersection. Everything else is visible but turned off. I'll copy this. It's possible to copy in one typed line on the command line, but I'll move it 2.5 to the right, or I'll copy it 2.5 to the right and move it 1.5 down. We'll go to copy. I'll select them. I'll move it 2.5 to the right, and I'll move this copy straight down 1.5. Okay, go tangent to tangent to do this top line here. That'll involve the tangent O snaps, which I don't recommend to be running. It's not one of the 5. So I'll use O snap overrides at each end of the first line. Okay, O snap override only lasts a single point. Click line, I'll shift right click, pick tangent. Expect it'll be about tangent right there. Asking for the next point, we're back to the 5 running O snap, center, quadrant, mid, intersection. Shift right click and use tangent O snap override again, and click where you expect it to hit. Hit enter to finish. Now the thickness of the flange is 0.25 all the way around. That's what TYP means. It looks the same, count on it being the same. I'll click O snap, set the view, or set the O snap amount to 0.25, enter, select, and put it on the downward side. Let's fillet these 2 corners here. All fillets, all 6 of the fillets are 0.25 radius. I'll hit escape to get out of the offset command, click fillet. Radius is currently set for 0. I'll select the radius option and change the fillet radius setting to 0.25, enter. Now I can click where I want to put those 2 fillets. Enter to invoke the last use command, click, there we go. Now, before we do these bottoms, I'm going to at least need this big circle to the left. So I'll mirror this large circle on the right, enter, about 2 points along the center line here. Enter to leave the original intact. Now I'll use the fillet command. Could use circle, tangent, tangent, radius, but then I got to trim the bottom of the circle. So I use fillet for this. Radius is set for 0.25 just from just a minute ago. I'll click radius and change the radius to 5. Enter. I guess it's going to hit about right there. I guess it's going to hit about right there. I'll offset. Go to the offset icon. Offsets can remain at 0.25 as it was before. Enter. Select what I want to offset. Select the direction I want to offset. I'll fillet these. Let's go back to the fillet radius again. Now it's 0.5. I'll set it back again to 0.25 and enter again there. Okay, I think we're just about to mirror this circle, these two arcs, and that line. I believe that's everything. Click 2D mirror command, select that arc, select the two lines, select that arc, and select that circle. Enter. Pick 2 points along the center line. Enter. Now for the three-dimensional part, I need to extrude everything to the right thicknesses as mentioned here on the right side of the view. Quarter, 0.5, and 0.75. Press pull is pretty handy if you got a nice clear shot at open areas, as I do for these donuts here in the three corners. I'll switch to the 3D modeling workspace down here on the status bar line with the little gear. Change it from from drafting and annotation to 3D modeling. And a shortcut for extruding these bearings would be the press pull icon. The extrude takes a few more steps to subtract away the small cylinder from the big cylinder. So press pull will make the pipe, so to speak, in one step. I'll come down in AutoCAD there. It's by the dotted lines, you see it selected this donut shaped area. For height, should be 0.75, enter. Press pull continues. I'll select same again, height 0.75, enter, and select 0.75, enter. Multiple option might have saved a couple clicks. Leave them all finished. Hit enter. I don't care much for this. I probably should turn it off. I don't know. I've never got the hang of it. I'm going to, instead of using the orbit 3D viewing fine adjustment tool, I'm going to slide down to free orbit. I find it's a little more versatile, has more capability. Now I'll rotate it, and things are looking good. Hit escape to lose the gerbil wheel. I'll change the visual style, and we'll change it back to 2D wireframe for now. Now I forget, I think by converting these cylinders, or by extruding the donut, I think I've eliminated the original circles. Let's find out. Erase. I'm going to select, I think this is a single object. Nope. It's 3 objects. So the circles are still there. Okay, eventually I'll move all the solids to the right. So just keep in mind that the original circles are still there. And later, I think you'll see there's some of these lines will still be there after you extrude. Let's go back to the top view. Anytime you use an ortho view here, double check you're still in the coordinate UCS you expect you are. World coordinate system's got that little square in the 2D model space UCS icon. There's a, what is it, UCS ortho set to, I believe, 0 will resolve that issue of having to check. When UCS changes a few, for in a few cases, when you change the view, at least these ortho views here on this drop down list will do it. Not sure about the cube, not sure about typing PLAN and the other type in. Anyway, let's turn these into closed polylines. That can easily be done by the crosshatch command, boundary option. Drop down in the 3D modeling workspace, drop down the draw panel, select this icon, and that'll put a closed polyline in the closed area you click in. I'm confident this is a closed area because I did it well. Click boundary icon, click pick points. I'll click in there, I'll click in there, and I'll click in there. So I'm forming 3 closed polylines. Again, be on the lookout. One or both of these lines, I think this bottom, the arcs, I think, will remain in one or both of the lines. I can't remember. Hit enter to finish selecting what you what you want to place the boundary closed polylines at. Hit enter. We'll extrude all, we'll extrude all 3 of them to 0.5 thickness. Let's go. Press pull should work. Probably. So we'll click press pull. Why did it not register? There we go. Click. Specify height 0.5, enter. Read it continues like erase and line. I'll click here, 0.5, enter. And I'll click there. Notice it detects the closed area surrounded by the circles, arcs, and lines. And I'll specify 0.5 height there. That's all we want to do. Hit enter to finish. Oh, I forgot to extrude this. I'll get that next. Click on the 3D free orbit. Remember, it's the second one on the flyout. We'll double check. Yep, everything has been extruded as I thought. Let's return to the top view. Good habit, glance down here to make sure. By the way, if you're in a different visual style like wireframe, you get this, and I don't believe there's a way to indicate that you're in the world coordinate system from the appearance of, of that icon. But the 3D wireframe does have that square to show you're still in the world coordinate system. Let's do the boundary and extrude this to 0.25. What's this? Close that. Where was I? Boundary. Come on, come on, come on. Select the area. Look good. I see dotted line all the way around this boomerang-ish looking thing. Type in 0.25 for the thickness we want to extrude to. Enter. That's all we want. Hit escape, enter. I believe space bar will work. We'll do a quick 3D free orbit. Yep, everything's looking good. Hit escape to lose the gerbil ball. To get a little more confidence what we're doing, we'll change it to conceptual. 3D rotated around. Everything looks good. Now check it out. We got, I think, 7 solid objects. 1, 2, 3, 4, 5, 6, 7. So toward the end of this assignment, you can union them all together if you want. I don't see a need to. So I'll leave them as is. Return to Z enter, P enter might get you back, but I'll go to the zoom, the custom or the standard view top. Double check. Oh, okay, I'm still in the conceptual. Change back to 3D. Okay, probably should have left it in the view I was. Now the hard part, centering the 1/4 inch web in the dead center of the flange and the bearings, and then centering the flange. Anyway, everything's got to be centered along the center line of the bearing. Let's synchronize the um, web with the flange first. We'll go back to a slight 3D view. Again, this is hard, the difficult part. We may need to snap. We might need to create some lines because we want to move the web from the midpoint of it to the midpoint of the flange. And unfortunately, not all of these intersections can be homed in with endpoint. I think quadrant will work. Let's find out. We'll go to move. We'll select the 1/4 inch thick flange, enter. I want to grab it from the midpoint. Okay, we got quadrants, but midpoint's not homing in. So we could either draw a line there and go to the midpoint, or there's a seldom used O-snap override, snap midway between 2 points. Let me show you that. Shift right click, select the O-snap override mid between 2 points. So you'll specify the point between two selected points instead of endpoint, midpoint, quadrant point, etc. Click that and it says, okay, what's the base point? Well, I want right there, that quadrant. Okay, what's the second point? That'll be right there, that midpoint or quadrant. So I got the flange held at the midpoint between those two selected points. Now to place it at the midpoint of the flange, use a mid between 2 points again. And I want to place this between that intersection and that endpoint. Interesting, that's an endpoint there. And rats, I probably should have forgot about moving it there. Let's undo. All right, let's try that again. Rather than let's catch these 2 points. Move, shift right click between 2 points. Oop, it escaped, sorry. Move, I'll select the flange or the web, enter. Base point, shift right click between 2 points, pick these 2 points. Now the second point would be shift 2 points and there to there. Okay, not sure. Now I got the flange center of the web. Let's change the visual style, do a 3D free orbit. So the flange is centered on the web. Now let's move the set of both flange and web and center them on the bearing. Change the visual style back to, let's go to X-ray. I'm trying to use that more and more. Okay, getting my bearings here. Okay, let me rotate it a hair, and I think I can. Let me go back to wireframe because this X-ray is not quite. I'm guessing I got a cheap video card. And the background lines are kind of dotted and a little bit hard to see. I'll go back to 2D wireframe. Okay, we'll go to move. I'll select three webs. I'll select three flanges in the web, enter. Shift right click mid between points to get to the center of this assembly of the web and three flanges. I'll go midway to there. Let's see, I've got the four pieces at that midpoint of the assembly. I want to place it between right in the mid place of the bearing. So I'll shift right click mid between 2 points, select the top, the bottom, and the top of the bearing. And I believe we're done. And as I warned you, there's going to be some remnants from the press pull. Let's do a conceptual. And there's that leftover line. I think everything is good. See some more leftover lines and arcs. Not a problem. Now to get rid of those leftover lines and arcs, I'm going to move the 7 solids as a round number to the right or straight down, whichever. We'll go to move. 1, 2, 3, 4, 5, 6, and how can I get the all right, I'll do that later. Hit enter, polar track on the x-axis. I forget what's a good distant round number here. And let's move it 7. Okay, remember 7, just in case we gotta get everything. Well, we will need to move the web. 7, enter. Left the web. I'll launch move again. Could have hit enter. Select the web, enter. Now polar track in the x coordinate or x direction 7, enter. There's our finished. Gosh, interesting. Did I study they left the circles? I think it was just a single object. I'm not sure why my list or my selection didn't indicate 3 objects, 2 circles in the solid. I do not expect everything to remain. Okay, I think we're done. We'll admire our work a bit. It looks good. I just got those, what I say, 3, 4, 5, 6, 7 objects. Let's do a list or a partial modify command. I think they've got 7 solids. Yep, 7 items found. Okay, if we turn on properties, let's see, I guess we get select one item, turn on properties and select, you'll see that all 7 are 3D solids. And when we look to analyze the properties of the large selection set, I'd say we're done. Next exercise might be to draw 3 views with viewports. We'll call it good enough here. We've created a 3D model of this toggle link or whatever you call it. Let's call it a video.